Good afternoon, everyone, and thank you for joining us. It is my honor to introduce our first keynote speaker for today, Professor Martin Jaatun. Martin is a senior scientist at SINTEF Digital in Norway and an adjunct professor at the University of Stavanger. Martin has held a wide range of positions, including scientist at the Norwegian Defense Research Establishment, senior lecturer in information security at the Bodø Graduate School of Business, and also he's a senior member of IEEE. And without further ado, Martin, the floor is yours.
Thank you for that kind introduction, Hanan. I will now attempt to share my screen and let's see if that works. How's that?
Oh, perfect.
Great. Okay, welcome everyone. I'm going to talk today about secure use of cloud computing for critical infrastructures. But first of all, I need to focus. Yes, there we go. So what is cloud computing? You may have heard the saying, there is no cloud, it's just somebody else's computer. And whereas this take by the webcomic XKCD is a little bit over the top, there is some truth to it. It's clear anyway that when you're using the cloud, you're not using a computer in your own basement. It's out there somewhere. Now, my own journey to the cloud started almost 13 years ago. So it was in early 2009, I believe, that my friend and colleague Chunming Rong called me and asked, hi, do you want to help me in establishing a new conference series on cloud computing? To this, I replied, sure, I have no idea what that is, but why not? Now, since then, luckily, I have learned quite a lot more about cloud computing, and we've organized a number of successful CloudCom conferences. The first one was in Beijing in 2009. Since then, we migrated into an IEEE conference. We're now known as IEEE CloudCom, or the IEEE International Conference on Cloud Computing, Technology and Science. Now, unfortunately, due to the pandemic, for the past 2 years, we've been unable to organize that conference, but we are confident that by next year, we will be back. So now, of course, organizing conferences is all good and well, and it's something that we like to do, and we like to interact with our peers, and also like to get away from our desks for a week or so. But in Norway, so the Norwegian word for collaboration literally means working together. And so we realized that, while we do enjoy organizing conferences, in order to progress in this field, we need to actually get a research project on this topic. That's exactly what we did but it sort of all hangs together because through our contacts that we gained from actually from the very first CloudCom conference in Beijing, we met with Shani Pearson of then HP Labs in Bristol, and we built on this acquaintance. And in 2012, we collaborated in writing a proposal to the EU FP7 research program. And we managed to secure funding for the A4 Cloud project, also known as the Cloud Accountability Project, which then started. So accountability is, it was back then a bit of a fuzzy concept, not very clear to anyone. Well, not at least not clear to me, certainly clear to some people. Interestingly enough, again, in Norwegian, there is no good translation of accountability. So through this project, we ended up in a definition what it means for an organization to be accountable, and particularly then a cloud provider. So an accountable organization must commit to responsible stewardship of other people's data. That means that that organization needs to define exactly what it does. So how does it treat information? What does it do with it, etc. It also needs to monitor how it acts. So one thing is, of course, to have a list of do's and maybe don'ts, but you also need to check that you're actually following that list, because there could be mistakes, there could be omissions, etc. So you need to monitor your own usage. And then if you do find that there are any discrepancies, you then need to remedy these in a timely manner, so without undue delay. So you ensure that if you say you're doing something, but you're not actually doing something else, you should discover this, and then you should fix it as soon as possible. And then finally, you should explain and justify any action. So this, in a way, goes also back to defining what you do, but you need to explain that to your users as well. So one challenging thing about cloud computing is these so-called cloud provider chains. So it's relatively easy if you, as an end user, you're using a single cloud provider, say A in this case, and you get all your services from A, and A is who you relate to. For I know, A may even have an office in your city. Now, however, the reality with most cloud providers is that it's not, seldom just one provider that will deliver all facets of your service. So an example here, so this is a simple example. Something happens at provider A. Provider A is the provider that you have a contract with, so it's clear that provider A will notify you, and you will be able to work out what happened and what you need to do. But say something happens at provider C. Okay, it turns out that there is another provider, provider B, that uses all or parts of provider C's servers, and then your provider, provider A, uses some other service from provider B that incorporates the service from provider C. So when something happens at provider C needs to notify provider B. Provider B then in turn needs to notify provider A. And finally, provider A needs to tell you what happened. So that's a little bit more complicated, but still simple enough. So then you have the case that, okay, this time something happens at provider B. Needs to go through the same process to notifying A and then yourself. But then, of course, what happens at provider B could also impact something at provider C, which then has a totally different customer, and that customer also needs to be notified. So the cloud provider chains make things a little bit more difficult, and you need to take care. Now this is true. So in the context of this A4 Cloud project, our main focus was privacy. So personal information, personal identifiable information, maybe sensitive PII. But it's also true, of course, for confidential information. So if there is something that happens with business confidential information at provider B, the same analogy holds. So first and foremost, if you want to be an accountable organization, you need to demonstrate willingness and capacity to be responsible and answerable for your data practices. And like I said, this applies to personal data, but also confidential information or business information. Now, of course, willingness and capacity are two different things. So capacity is about the mechanisms that you have, maybe the procedures that you have, but then you also need to show willingness to do this. And that is also part of the whole accountability thing. So then shifting gears a little bit, we can then make an example from a critical infrastructure. And in this case, I have chosen a water utility as an example. And in this case, you have the water utility that needs some kind of service, software-based service from a service provider, which could be a software developer. We don't know that, but it provides some sort of service. Now, this is what it looks like to the water utility. It's buying a service from this service provider. The water utility does not need to know, strictly speaking, where this service is located. So when, for instance, it's a web-based service, it will maybe have an address in Norway. It will have an address something.no. Looks like it's in Norway, but in reality, it may look more like this, so that the software developer or service provider that's offering this service is actually offering this through a cloud provider. So when the water utility thinks, or it may appear to the water utility that it's actually using some Norwegian server, it's in reality actually using a cloud computing service that could be located, well, basically anywhere. This could be any of, say, of the big three. It could be Microsoft Azure, it could be Google Cloud or Amazon Web Services. We don't necessarily need to know about this. And again, you can see the contours of the provider chains as well, because yes, the main provider, the main cloud provider, they may have their cloud, but it could also be that they use portions of services that come from other cloud providers, and maybe they use storage services from yet another cloud provider. So when we're talking about critical infrastructures, we, at least in Europe, we quickly end up at the NIS directive, so the Directive of Network and Information System Security. It defines cloud much the same as the National Institute of Standards and Technology in the US, so sort of the accepted definition of cloud computing. And that's good. However, the NIS directive only mentions cloud in a couple of places. And basically what they say is that, yeah, it's fine. You can go ahead and ask cloud service providers for additional security measures beyond what they would normally offer. It's sort of kind of them to allow you to do that. And then you're also allowed to enforce your own national security requirements on cloud services. This is maybe less helpful, because what does that really mean? Well, you need to be more explicit about the security requirements that are involved. Now, I have now pulled up an example, and the source of this example is the Cloud Security Alliance, partly because I'm past president of Cloud Security Alliance Norway section, but that notwithstanding, the CSA, they have a quite detailed list of security requirements for cloud services known as the Cloud Controls Matrix. It's currently in its 4th edition, and new editions keep emerging. Based on this and other previous work, we actually made some specific suggestions for the water sector, which, well, sort of postulating here that they might fit other critical infrastructures as well. And in this list of requirements, we have requirements related to data processing, to data transfer, to access control, to data storage, and many more. Now, what kind of requirements? So I will provide you some examples. I'm not going to go through all these requirements. That would really bore you to death, but I will provide some examples. So the first one, requirements related to data processing. So the first category is about isolation. And that is, it means to ensure that if you have one customer with its set of data, it should be isolated from other customers and their sets of data. And the requirement here is that all in-memory data shall be segregated from data belonging to other customers. So basically, it's like the illustration. You have Mr. Green here on the left, He has some data running in memory in his at his cloud provider, and he wants to avoid Mr. Black on the right from accessing that data. Now this, in a way, this seems like a very obvious thing. And it's true. The big cloud providers, of course, that they know how to deal with this. However, there have been examples in the past where this kind of requirement actually hasn't been fulfilled. So the same with the next bullet here, to have mechanisms that ensure that different virtual machines do not influence other virtual machines of other customers. There's a famous paper by Ristenpat et al. With a catchy title, "Hey, you get off my cloud," where they actually show that it's possible to extract key material from other virtual machines if you are co-located. And so there are, of course, various additional mechanisms that you can use to ensure this kind of thing. So there are, and then also this also goes back to the kind of service level agreements that you end up negotiating with your provider, which, of course, again, your mileage may vary. Different cloud providers will be willing to make custom service level agreements to varying extents. It's likely that if you do go to one of the big three, they will most likely offer you a standard SLA, and will probably not be willing to negotiate the terms of that SLA. But there are options such as you can ensure that, for instance, your particular virtual machine is running on a separate physical machine at given times, to ensure that so this is one way of ensuring that you cannot have other customers that have access to your virtual machine. Yeah. So there are, of course, also other requirements, and another famous one is physical location. So you may need to ensure that your data is processed in a specific geographic location. Now, for European businesses, for European, but particularly, of course, for European critical infrastructures, the rule is that you want your data to be processed in data centers based in Europe. So depending on what the offering is, you need to actually consider where is the provider offering to host your data, and can you ensure that your data is only processed and stored in Europe or even in your country. Now, this is also becoming easier, actually, since, for instance, so Microsoft even have data centers in Norway. They have at least 2 that I know of. So that's a good thing. Now, recent events. So it used to be that we had this agreement between the EU and the US called Safe Harbor, that was intended to enable the processing of data and personal information about European citizens in the US. Now, that agreement was struck down because it was proven it was inefficient, didn't provide sufficient protection. We then got a new agreement called Privacy Shield, which seemed to do the job for a while, but that was struck down also. And the latest ruling by the Schrems II committee seems to make this even more difficult. So currently the jury is a little bit out on this, to what extent you currently are able to use specifically US cloud providers for some specific critical infrastructure tasks. I know that opinions differ on this. So my conclusion on that is that you probably need a lawyer. There are more examples. So, and this is, again, something which seems very obvious. So requirements related to data transfer. So encryption. And when you are transmitting data, make sure that it's not transferred in clear text. And so this specific requirement, when you're uploading or downloading data to or from the cloud service, it should be encrypted. And integrity is exactly the same. Up and downloading of data to and from the cloud service is integrity protected. And assuming you're using the correct algorithms, you can also have algorithms that actually ensure both things at once. It's a bit like almost Kinder Surprise. Looking a little bit into this, so the first thing about protecting uploading and downloading to the cloud, that's the first leg here, encryption in transit, and it's fairly well understood and not so difficult to understand. Now, for most purposes, if you want to do anything with your data in the cloud, then you need to have it unencrypted. Of course, it's possible to use a cloud service to just store encrypted data, but for most people, that's not that useful, because usually the reason why you are uploading things to the cloud is because you want to do something with it. And yes, I know there are things like homomorphic encryption and secure multi-party computation, but the reality is that we are not quite there yet for the general case. So in general, if you want to do anything with your data in the cloud, and I sort of argued that you normally would want to do that because you want to use the processing power, etc., that's available in the cloud to do heavy calculations and projections and all that nice stuff, then you need to have it unencrypted. Now, so then that's sort of the second stage here. You are doing something with your data, and you need it to be in an unencrypted state. But then once you are done, you will probably want to store it, and then you will have it encrypted at rest. It's still not entirely easy, because in order to do that, of course, you need to do key management, and key management is one of those famously difficult things. And in the general case, you will need to share your keys with the cloud provider, because how else could the cloud provider encrypt the data? There are various solutions that sort of deal with this, but sort of it all boils down to the fact that at some level here, you need to trust the cloud provider. It's true, though, that not all critical infrastructures are created equal. And I also sort of an alternative title to this is a tale of two stations. So on the left, you see an aerial photo of a small sort of municipal railway station in my hometown of Stavanger. And it's known as Paradis, or Paradise. Yeah, if you look slightly below, you can see the marina where my father used to have his cabin cruiser. And you get the idea that whereas people who know Stavanger, they know it's not a huge city by European or American standards, but it's sort of fairly densely populated. You get this idea when you look at the houses, etc. Now, contrast this with the station of Hell, which is just outside the airport of Trondheim. So just looking at the aerial photo, you get the impression that, yes, this is in the municipality of Stjørdal. And this is definitely a more rural municipality, and you also get the idea that the expected service level, or sort of the number of people served by these municipalities, that's different. So and considering a small, say, water network operator, your admin team, your security IT support staff, it may look like this. This is your IT responsible, your sysadmin, also happens to be the local school minibus driver and in charge of coaching the locals under 14 soccer team. Now we can contrast this with how a typical, well, just chosen Google. This is of course not Google, but it tells something about the scale. And this is the point I'm making, is that if you are a small actor, and it doesn't really matter how critical infrastructure you're running, but if you are a small actor, you will have difficulty to actually retaining the number of skilled employees, and you will have difficulty to have the resources to deal with security by yourself in a good manner. However, the big cloud providers, they all have very competent and very big security teams, and they handle basic security things in a very, very competent manner. There's also other advantages by putting things in the cloud. So the cloud provider offers defense in depth. It will have perimeter control. It will have most likely we use additional services such as content delivery networks to protect against the distributed denial of service attacks, for instance. Further in, it will have systems for identity management and key management, etc. And it will operate with virtualized networks and virtualized applications, etc. So these are several layers of protection that a single operator, if you want to do this yourself, you will be hard pressed to match it. I'll add a small real life story here. At the beginning of this year, there was a ransomware attack on a again, small Norwegian municipality known as Østertoten, so East Toten. Most of their systems were actually put out of commission for quite some time. But specifically when it came to the water and wastewater networks, they continued pretty much as before, and many of the sensors and sort of extra IoT gadgets that they use to control various aspects of their water delivery was actually running in the cloud. This is some inside information that I have. In this case, it actually protected them because this part of the operation was not actually affected by the ransomware attack. And as you probably know, ransomware is highly relevant these days. Well, I have to admit, of course, that it's not all roses. There is, I mentioned the big three. Maybe I should say the big four, because in addition to the US players, you also have Alibaba, the big Chinese cloud provider. The fact that these are now so big is could be a cause for concern all of itself, because it means that if anyone should successfully attack a single of these big cloud providers, a large portion of providers or services that's currently being provided over the internet will be affected, because there's so many people who use or so many businesses who use, for instance, Amazon in offering their services. This is a commonly referred fact, for instance, that when Dropbox was first launched, it didn't actually have any infrastructure by itself. It used all the services that Dropbox used and then sold on to their customers was actually provided by Amazon Web Services. This kind of, and this also brings us back to these provider chains, because suddenly you could find yourself in a situation where a link in your chain is missing due to an attack. So it's sort of to repeat a popular phrase, it's buyer beware. You need to take this into account also in your risk management. Right, so there is some movement also in Europe on this. ENISA has published a draft version of the European Cybersecurity Certification Scheme for cloud services that came already December last year. And it's based on the structure and wording of the British Standards Institute's C5 2020 criteria. This is sort of, I guess, interesting now that we have Britain out of the EU. I'm not sure what will happen there, but they've also added additional input from the SEC non-cloud scheme, which is an initiative from the French National Cybersecurity Agency, also known as ANSI, so note the double S. Also ISO IEC 27002 and the web version, or the cloud version of that, the ISO IEC 27017. Now, for some of us, it's I wouldn't say depressing, but it's interesting to note that they don't mention the Cloud Security Alliance cloud controls matrix at all. It could be, of course, part of the not invented here syndrome. Also, that CSA is originally a US-based organization. I won't dwell on that further. So I provide here a list of resources. First, the Cloud Computing Association, which is the association that Chun-Ming Rong and myself funded to serve as the umbrella of the CloudCom conference series. Then we have the IEEE Computer Society Technical Committee on Cloud Computing, TC Cloud. You can join the LinkedIn groups of both of these. There's also if you are an IEEE member, you can also join the TC Cloud via the IEEE Technical Committee system. And if you're interested to know more about the A4 Cloud project, there's a link to it there. And with that, I conclude my presentation.
Thank you so much, Martin, for all the insights and information. I quite enjoyed the talk. So I'll give a couple of minutes for the audience to post their questions. But meanwhile, I would like to ask you, what would be your top recommendations in terms of, in actually in both terms, in terms of research, what would you suggest for young professionals to start looking in? And in terms of professionals and industry sector, what would be your top recommendations there?
Okay, to start out with the research, it's a sad fact that research funding, it follows buzzwords. So back in 2009, there was a lot of cloud buzz. And if you like me belong to some of these mailing lists from various IEEE organizations and so on, back then in 2009, 2010, there were just a huge amount of like PhD scholarships being offered to do anything to do with cloud computing. I've hardly seen any PhD scholarships being offered in the cloud space for the past, I don't know, year or so. So that's a little bit depressing, because I strongly believe that there is still a lot of interesting work to do here. Now, to just take one specific example, it's this, referring to my slide about confidentiality protection. So I still believe that to achieve a fully sort of, for instance, fully homomorphic encryption scheme that would work in for real applications in real time, that's something that I still believe that there's a need for. And it's also something that might allay some of the more regulatory fears, as I sort of hinted at. One of the problems with first the safe harbor and then the privacy shield is the US legislation, such as the Patriot Act and similar legislation, that allows US, well, the US government or US government agencies, such as the NSA or the CIA or the FBI, I wouldn't know where to start, but it allows them to access information about other countries' citizens, as long as it's hosted on a server that's being managed or controlled by a US company. Now, what that means, at least this is one interpretation. Again, you would need to be a lawyer to really be able to argue this, but one interpretation is that if you have, as Microsoft does, a data center in Dublin, and in that data center, they are hosting, say, Hotmail web mail accounts, then American authorities should be able to go to Microsoft and say, okay, we want copies of all your emails, of all your customers, and we want it now. Now, I must admit that there was a very high-profile case about this, where American authorities, and actually it was even I believe it was like a small court somewhere, I don't know what sort of district court or something, where a judge had issued a demand that Microsoft hand over email information for, I think, was a particular customer that was suspected of probably terrorism. That's usually the way it goes. And Microsoft actually fought this in the courts. And this is a few years back, so I don't actually remember what the final verdict was. I do know that they did win in several sort of instances, several tiers of the American court system. But it's this fear that somehow creates, it has this so-called chilling effect on use of American cloud providers, because so I've heard, for instance, that particularly again after Schrems 2, that there are several public, so you would call them critical infrastructure organizations in Sweden. That's the specific case that I heard, that basically now have the stance that we cannot use American cloud providers because of Schrems 2. So I believe that although there are probably legal ways to address this, there are various you can do this through contracts, agreements, and so on, probably. But I believe in a two-pronged approach. So if you can have a technical solution to that, that would help improve things. Yeah. And the second part of your question was?
For the industry sector, so what would be your top recommendation in that sense?
Well,
what should new companies do, like those without very much experience? And then I'll jump into the audience questions. Yeah.
So I think my answer to that would just go back to the usual cop-out. It depends, because like I said, small organizations, just like smaller municipalities, are probably better off using a cloud provider anyway, because there's no way that they will be able to cover all the bases with their own resources. So in that case, it's actually better to pool your gold, so to speak, with the cloud provider. If you are a larger institution, larger company, well, you may well have those resources, and you'll have to actually do the math yourself and decide what is the best approach.
Right. Thank you. So we have a few questions from the audience. So first is from Tim. Regarding the problem of aggregation risk concentration within the major cloud service providers, do you have any ideas for how this could be addressed?
It's a typical hard problem, but of course, this is also, I've heard, one of the reasons why this legislation in EU, it also motivates this legislation, because once you have disincentives to using American cloud providers, also sort of the flip coin of that is that you have incentives for European providers, and so it could open up the market for smaller players who could potentially offer you more of those solutions. And I do know, for instance, that at least for very simple services such as storage, there are lots of local providers that can do that for you, and they will still be probably better security-wise than doing this yourself.
Right, and a follow-up from Tim, is there a need for more powerful international regulatory mechanisms?
This is it's a good question, and it's I think this will have to be an ongoing thing, because yes, probably we need to have agreements at least that make it possible for us to use services in other countries than or other jurisdictions, so to speak, because that is the requirement from the GDPR is, I believe, the same as it used to be in the old data protection directive. It's about that you're not allowed to transfer personal information to jurisdictions that have insufficient protection. So, and that's of course the case in the US. That sort of just out of the box, the privacy protection that's offered in the US is much worse than what is offered in Europe, because it's a totally different philosophy. In the US, data is owned by whoever collects it, whereas in Europe, data belongs to whoever it is about. So that's a fundamental difference. And so in order to enable more collaboration, yes, you definitely need more regulation, and you need to have a regulation which also then handles crazy US judges, so to speak.
Fair enough. So the second question is from Dr. Cyril. So great talk, Martin. What is your opinion around follow the sun model that most cloud providers practice, since their DCs are spread across many geographies? So how does this impact, say, the EU data sovereignty clause?
It's definitely a challenge, because in order to follow the sun, then referring back to my previous slide with the globe, pretty soon you'll find yourself in a jurisdiction that's not covered by this sort of sufficient protection. And I believe that unless with current technology, current solutions, there is a lot of data that you simply cannot use in this configuration. So particularly then sensitive personal information, no, you cannot store that in Mumbai. That's just not allowed. Right.
The next question is, you say users have to trust the cloud providers. What about conflicts of interest that providers want/needs to be profitable?
That's a very good question, and this was addressed in a recent article by Bruce Schneier and a colleague, where he pointed out that so strictly speaking, if we're very cynical about it, security is an externality, I believe the word is, to cloud providers. So, and by that I mean that if something bad happens to a customer's data, it doesn't affect the cloud provider directly, because it's the user, the customer, who's hurt. The cloud provider itself isn't really hurt by this. And also, so we have experiences in the past where even if there's a big data breach from a company, from a service provider, that doesn't really affect them. There might be a very small dip in share prices, but it quickly recovers, and they basically can go on as before. So that's a conundrum. It's clear that the providers need to honor certain minimum requirements. They need to be profitable, yes. So it's clear that for instance, again, take the follow the sun. It makes perfect sense for providers for the big ones such as Google and Amazon, etc., to offer this, and it also it's more affordable for them. They can do lots of stuff during the night, handled by somebody in a different time zone. But you need to counter that with basically you have it's buyer beware again. So you need to be aware of what your requirements are, and then this sort of goes back to our proposed list of requirements, which are more sort of like a buyer's guide. You need to know when you're buying services from provider X, which requirements is that provider actually able to fulfill. And then, of course, you need to follow up on what happens when the SLA is broken. That's, people have spent years researching that specific thing in itself, and not always so encouraging, since they the consequences typically are that the customer gets some refund on the cost of the service and so on, which doesn't really help a lot, does it? If your personal data is in the wind, doesn't help if you get a 3 months of service. So,
right, fair enough. So the other question from an anonymous attendee is, what's your stand on organizations having a multi-cloud strategy, and could this address the security risk that if one cloud provider is breached, then production could be provided by the other? I hope.
Yeah, that's also a good question, and is something that I do believe is an advantage. Of course, this is something that works in terms of availability, of course, so that if provider A is out of commission, as you know, it happens. There are cases not so long ago where people can't access Amazon Web Services for some time. Then you can have access to data at another provider, and you can also have various ways of synchronizing data between cloud providers and so on. This doesn't help, of course, with privacy. So it doesn't really help you if you have your sensitive PII exposed on one provider that's still exposed, even if you can use the services on another provider. So, but what it does is that it opens up for the possibility of maybe using new mechanisms. So I have myself written some papers about some science fiction approach where you actually split up the data between the various providers. Probably a bit naive and optimistic as a workable solution, but and this is another area where, just as with the protecting information on a single provider, we could imagine that budding PhD students and others could look into this sort of secure multi-cloud strategies, both for availability, but also for confidentiality and privacy.
Fair enough. AWAL say, great, thank you for your answer. And Tim has sent us a comment. I'll read it out loud and then you can, if you want, expand on that. So Tim is saying the problematic US registration in the USA Freedom Act, which replaces the former USA Patriot Act because the act requires US organizations to disclose information to the US government without notifying or consulting with the data owners. For example, using what is called blind sapons, the best technical protection measure is for the customers to encrypt data using reliable encryption mechanisms and not allow the US cloud service providers any access to the key.
Yeah. Yeah. So of course, the comment is perfectly correct. That currently that seems to be the solution, and also so I know, for instance, that Norwegian health authorities, they have adopted this approach where they in their case they use pseudonymization, so they don't store health data with names of patients, and they would then store the key, so the mapping between the pseudonym and the actual patient name or other identifier off cloud. And that is, of course, currently the only way you can do that. Now, like I said before, to me, this seems like a very promising area of further research. How could we do this technically without requiring this kind of manual separation? Yeah, so that's a hint for all you PhD students out there.
Right. Well, actually, a controversial question regarding research. I'm not sure, but why do you think there is not enough fund, not enough research, not enough PhD students? Well, you've mentioned a lot during your talk and during the Q&A time. So why, in your opinion, there is not enough, I don't want to say interest, but why is not a focus? Is it less of awareness? Is it that large companies do not do this kind of, what are your thoughts?
It's multifaceted, but the first thing is, of course, as I mentioned, that it's about fashion. So that the various research councils, and also in the framework programs in the EU, they focus on stuff that's new and exciting, and it's always a new flavor. I think still, so blockchain, for instance, is still a buzzword. And it's still, I still see a lot of, actually now it's more postdoc positions. There used to be lots of PhD positions. Now it's a lot of postdoc positions in blockchain out there. It's sort of, this sort of ties directly to what's being offered from the various funding agencies. Because as you probably know, that there is a lag. You apply for a research project, and if you get it, then you need to hire the PhD students, and sort of the whole thing takes a year or two, and so there's a lag in the what kind of PhD students, what kind of postdoc positions are being offered. So the other thing, of course, is that I find that, and that's sort of again an unfortunate thing. It's fairly difficult to engage industry in high sort of or deep research. So you might, of course, various people, different people have different experiences, but it might sometimes be easier to get companies to involved in innovation projects. So things with a high technology readiness level, things that might actually result in a product, maybe by the end of the project even. Whereas the kind of more foundational research that many of us would like to do, there you're looking at a horizon of 10 years after the completed project before this can actually be a product. And unfortunately, most companies don't want to wait that long. They don't have that long of a horizon. They want, you know, okay, it's as it says in the film, show me the money. They want something that can actually increase their revenue quick.
Right. And don't you think that cloud service providers should, or why don't they invest in this kind of research?
Yeah, I guess they do invest on a certain level. But I don't know. It could also be the fact that they're just so busy earning money.
Right. So I think that's enough of questions for me. But thanks again, Martin, for all the great insights and the brilliant discussions. And thanks for everyone joining us today. So I want to remind you that in just over an hour, we'll have our second keynote today by Dr. Eliana Stavro. So I'll be looking forward to seeing you all there. Thanks again, Martin.
Thank you.